The first step to identifying the reactions is going to be to write out the chemical formulas. So iron 2 chloride is FeCl2. That is an aqueous compound, and that's going to react with chlorine gas in order to form iron 3 chloride. So we're going to have 3 chlorines over here, and that is also going to be aqueous. Now we need to have an even number of chlorines because our chlorines are doubled on the reactant side. So we have 4 chlorines on the reactant side and only 3 on the product side. If I put a 2 here so that we have 6 chlorine, then I would like a 2 here in front of the iron 2 chloride. Now this is called a synthesis reaction. This is also a redox reaction because we do have the oxidation states changing. Number 2, we have zinc sulfide, and there's no indication what the phase of zinc sulfide is going to be. I'm going to call it solid. And we have oxygen. Now, oxygen is going to exist as a gas in its normal state. And that's going to form zinc oxide, which I'm also going to say is a solid, and sulfur dioxide. Now, sulfur dioxide is going to be a gas. So what type of reaction is this? Well, this is a redox reaction. We do have a change in oxidation state. The zinc isn't changing state, but the oxygen is. You see the oxygen is a 0 here, and I don't want this to get confusing, but in its elemental state, oxygen has a oxidation state of 0, and over here it's a -2, but here we have also a -2, this sulfur is a +4, and the sulfur was a -2. So you see, we do have a change in oxidation state with the sulfur and the oxygen. So that is a redox reaction. Number 3, we have silver nitrate, so AgNO3, and that's going to be aqueous, and that's going to react with nickel. Nickel is a metal, it is solid, and that will form solid silver. And nickel 2 nitrate. So that means I need to have 2 of these. That will be aqueous. And I'm going to need 2 of these and then 2 of these. So this is a redox reaction. This is also a single replacement or displacement reaction. Then we have lead to nitrate. So PbNO3 that is an aqueous compound, and that will react with sodium carbonate, Na2CO3. We'll call that aqueous as well. And that will react to form lead carbonate, so PbCO3, I don't know the phase yet, and sodium nitrate, NO3. So that is aqueous. We're going to need 2 of those. I'm going to come over here to my solubility rules, and I'm looking for carbonate. Most carbonate compounds are insoluble except group 1 metal cations and ammonium. So this is going to be a solid. So this is a precipitation reaction. This is also a double displacement reaction. Then number 5, we have barium hydroxide, which will be BaOH2, and barium hydroxide is soluble, so that is aqueous. And we have iron 3 sulfate, so that's going to be Fe2SO43. And I'm looking for sulfate. Sulfate's usually soluble, so that is aqueous, and that will react to form barium sulfate, BaSO4, and that is insoluble, so that falls out as a solid, and iron hydroxide, FeOH3, and that iron hydroxide, they're usually insoluble, so that is also going to be a solid. So this is a double displacement. This is also a precipitate reaction. Mercury to nitrate, so we have HgNO3, and we have 2 NO3s, and that's going to react to form mercury 2 oxide, so HgO and NO2 and O2. So this is going to be gas evolution. There's gas on the product side. This is also a decomposition reaction. Copper, which is a solid metal, reacts with sulfuric acid, which is going to be aqueous, in order to form copper sulfate, which will be aqueous, water, which is a liquid, and sulfur dioxide. Sulfur dioxide is going to be a gas. So this is gas evolution. This is redox because we have the oxidation state of the copper changing. You see it going from a 0, elemental form it is a 0, to an ion of +2. And let's see, what else is changing? It's probably the sulfur. Probably the sulfur there. Number 8, for each of these reactions, we're going to identify the type and we're going to write the names. So this is mercury 2 oxide is going to decompose into mercury and oxygen gas. So this is decomposition and gas evolution. Here we have a combustion reaction, and this is going to be methane and oxygen gas will form carbon dioxide and water. Here we have ammonium nitrate will decompose, so this is a decomposition reaction, into dinitrogen monoxide and water. Here we have tetraphosphorus decoxide reacts with, and the formatting is strange, but it reacts with water to form phosphoric acid. Here we have zinc sulfate reacts with sodium hydroxide to form, that is, zinc hydroxide and sodium sulfate. And I forgot to say what kind of reaction we had. So this was decomposition. I think I said that. This is a synthesis reaction. We only have one product, so we are synthesizing it. This is a double displacement. And here we have titanium chloride, and this is titanium 4, reacts with magnesium to form titanium, and magnesium chloride. So here we have a redox and we have a single replacement or displacement, however you want to look at it.